Hi guys, I'm gonna start number 696, count binary substring. Let's start the timer. Given a binary string S, return the number of non-empty substring that have. Given a binary string, what is binary string? 0 and 1? I don't know. So return the number of non-empty substring, non-empty, that have the same number of 0 and 1s, and all of the 0 and all of the 1s in these substrings are grouped consecutively. Substrings that occur multiple times are counted the number of times they occur. Given a binary string S, return the number of non-empty substrings that have the same number of all the zeros and all the ones in this substring are grouped consecutively. Okay, number of non-empty substring. So 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1. Counted the number of times they occur. Okay. So here 1, 0, 1, 0, 0, 1, 1, 0, 0, 1. Okay. One of the way we can solve this is starting from here. Let's say the next number is same with this one. We can mark here and then mark here too. And then now it's different. So let's check whether there are two. So how many and how many? Okay, so if there is 1, 1, 0, 0, 0, 0, 1, 1, you can say there is 1, and also there is 1, which is this one. And then starting from 1, 1, 1, 0, 0, okay. So this is 1, there is another 1 in between here. Now from here, so here I'm thinking like interesting. I think like 1, 0, 0, 1, 1, 1, 0, 1, 1. Yeah, here this is 1, and then 2, and then 3, and 4, right? So we know that this has 4. So 3, 1, 2, right? So here 2, 3, we can find 2, right? And then 3, 1, we can find 1. And 1, 2, we can find 1. So, first we're gonna convert this to this. Then starting from this, 2, 3. Well, if n m and n is smaller than m, then we can say that there is n number of substring. N number of what's the name of substring? Substring. So smaller one. Okay, so then this is string, not vector. Okay. So we're gonna create this vector v, and then for char ch in s. Current ch, let's say this is some empty number. So if ch equals current ch, then we're gonna increase. I'm thinking like instead of vector, let's use q. Because in case of vector, we need to maintain count q. We need to maintain the index, the last index or first index. But in case of q, it will be easier. So if this is different, then we're gonna push this. This is int. I'm gonna push 1. Okay. And else count q front plus not sure whether this work because so what you can do is reference count, and then we can do this. So the one in the queue this is not yeah, let's use stack, and then front, and then we'll increase 1. So let's check whether, for example, if we have 1 1 0 0 1 1 0, so initially this is empty, and I don't know whether this will work. Let's 2. So they're different because right now we have 1 here, so 1 is pushed, which is the count, and then and then we'll go to the next one. And then prev, then now this is 1, and then this is 1. So here we're gonna increase previous this one to 2. Now this is 2, and then ch, this is also pushed to here, right? And then now ch is 0, so they're different, so we're gonna push this, and then end, so we'll return. So as length is greater than 1, so now we have while stack not empty. What we can do is that int prev count stack the pop, stack the top, and then stack the pop. So prev count previously it was 2, 1, so this is 1, right? And then int current count. And we're gonna do this. And then int min count equals to the min current count. Okay, so min, so now what we know is that we're gonna int return value is initially 0, and then ret, and then return ret. So here, what if we have only 1? In the case, I mean, what if the input is just length 1? In the case, the stack will have 1 as the count, and here prev count is 1, and this is empty, and return is 0, so it will return. And after doing this, we're gonna do current count, right? So let's do this one, easy one. So I did this, and then let's do this. Here we push 1 is pushed, and then prev is 1, and then next ch is 0, so we push, so this will be pushed into stack. And then here prev count is currently this one, and then after popping this, min is 1, so 1 is returned, and after popping this, min is 1 is returned, 1 is returned, and then the last one, so 4 will be the answer, right? So we got the correct answer. And for this one, we know that 2, 2, 2, 2 will be returned, so 2 and another 2 and another 2 from here, and then and then return will be 6. Okay, so I think this is the answer. Here the bad thing is that we use stack, so we have the O of n space complexity at the worst case, and then time complexity is O of n. The time complexity pretty good, but what? This does not work? No member name front. Top. Yeah. Phew. Oh my god. This is so slow. Yeah, very slow. So I guess we should not use stack. So the way we can do is that by scanning this, we got 2, and scanning this, we got 2, and then we can calculate 2 count. Well, let's do that. Int prev count is 0, and let's remove this. So instead of doing this, let's create current count zero. So here, instead of doing this, current count plus plus count is 1, and then here what you're gonna do is current count increase, and then prev count current count. So here what you can do is that you can do here. So if they are different, so current count and prev count, and get the minimum and return here. So initially, so let's take this case. So when it is 1, here they're different. So initially this will be 0, so return will be 0, but this is I wonder whether this is correct one. I mean, logically, when they're different, so initially, they're different, but then current count is currently 1, right? So actually, it's not current count, it's previous count, prev count. Anyways, so let's do this. in case of this 1 0. So here 1, so will be initialized to 1, and then the next thing is 0, so they are different. So they are different. So 1 is now privacy, and next one is 1. And then 0 here, preb so instead of this 1, to this, and then preb ch is sk, which is 0, and then we call preb C1, let's do that, C2, old, present. So here present is 1 because of this. Okay, so
오빠 배고파?
아니
그럼 나 샤워 좀 할게.
So what we're gonna do is if sk different from sk k minus 1, then what you're gonna do is recent old, and then recalculate. So old now recent will become old, and then it will be 1 because they're different. So and if they are same, see recent. So with this seems like they are pretty almost same as before. So in case of 1, this will not be called, so 0 is returned. So let's do this. So 1, so we have 1 as a C recent, and this start from 0, so they're different now. So will 1 0, so we'll return is 0, ret is 0, and then recent is 1, so old will be 1, recent is set to 1, so they are both 1 now. So next turn, this is 1, so they're different. The previous two ones are different. I mean, they're both 1, so return is 1. And then here, another 1. And here, another 1. So here, 1, 1, 1, right? And then after doing that, we need to do this again. Should we need to do this again? So the answer is 4, but this is 3. But if we do this at the end, so for example, in this case, if we do this, this is 2, and this is 2. Yeah, this. So think about whether this works. Yeah, I think this will work. Yeah, it's a bit faster. So let's see the approach group by character. Yeah, this is what I did. So it has something called group. Yeah, this is what I did, and this was kind of slow. Linear search, we can amend the approach to calculate the ends on the fly instead of starting with a low member prev to end the current group. Yeah. So here, yeah, it's almost same. Almost same. Yeah, it's almost same. Yeah. Okay. So took some time, even though this is not very difficult problem. So what is this? Imagine string 중 how can I write this description simpler? string s. Is this correct? Okay, let me finish the live cast.